Hi everyone, welcome back. I'm Kimberly Llewellyn with Positive Energy out of Austin, Texas, and we are discussing Manual J load calculations. And in this section, we'll be talking about the inputs required for a quality Manual J. So this is the information builders that you should be providing to your mechanical designers or your HVAC contractors. And mechanical designers and HVAC contractors, this is the information that you should be requesting from your builders or homeowners. We start with a good set of building plans. We'll talk in a little bit about what kind of information you're looking for on those building plans. Next, we need to make sure that we've got geographically based design conditions. Those may be dictated by your local code or your default energy code. Assembly specifications are the next category of inputs that are really important. We'd be talking about your wall assemblies and types, including insulation, siding, roof type, again, insulation, amount and location, windows specifications, as well as floor type. Next, we really need to know where your HVAC and mechanicals are located, and we will show just how impactful that can be, a change in the location of your mechanical equipment. And then your home performance goals, and what we're talking about there are your infiltration values, also called blower door results, or your ACH 50 number. ACH standing for air changes per hour, and your duct leakage goals. So we want to make sure that that's what we're starting with, and not sizing our equipment based on an estimated, you need about a ton for every 500 square feet. That used to kind of work, and sometimes it still does, but we don't recommend it. So I'd like at this point to introduce you to what I consider to be the most important report that comes out of the load calculation, in case you're not already familiar with it, and that is a load preview report. This is the report that your third-party contractor will have on hand when they come to test out your systems in your home. And what's probably most important to them would be that highlighted column, which is the system cooling CFMs. Those are the allocated flows for each room. But what we're going to be looking at is that net gain column. And I'll be pointing out some numbers over there a little bit later. So let's talk about building plans for a minute. A good set of building plans will have the following information on them. You obviously need dimensions. And if you have dimensions like numbers printed on the plans, you want to make sure that you check that with the scale specified on those plans. Sometimes they're wrong. It would be very useful to have elevations along with a floor plan. You can sometimes deduce what your elevations look like more or less if you have a roof plan with overhangs, and if you have window dimensions printed on those floor plans. But windows being so important, it really helps to have those elevations so that you can get your projections or your overhangs for the windows, because that does have a very large impact sometimes on the load results. So we want to make sure that we're starting there and not just the best guess, right? So one thing that we hear, not frequently but occasionally, is we've got practically the same floor plan as we do with that other house where we already have a load calculation. So do we really need one for this house? And the answer is it depends, but usually yes. I'm going to show you, this is not the most dramatic difference actually in the load outcomes, but this is an example where we were told that the plans were practically the same and the homes were being built practically side by side or down the street. But look at the square footage. The conditioned floor area is off by 250 square feet, which is the size of a good room. the flows are different for those spaces as a result of this being a different floor plan. And so that gets really important with, for comfort and also for your test out. So generally we say different floor plans. I shouldn't say generally, almost always we say that different floor plans require different specific manual J's. So we're going to take a little break there, and when we come back, I'm going to tell you something about the ASHRAE Handbook of Fundamentals. Okay, let me introduce you to the ASHRAE Handbook of Fundamentals. This is a very important reference book for many of us. And in this case, this is where we, for manual J load calculations, this is where we get our geographically based design conditions, which are based on the climate data. So you can see you've got different values for, even for different cities within a given state. So you want to make sure that your home is located in the proper location, and that's information that gets put into the manual J software. For cooling, we're using these 1% values here in this column under cooling, and the dehumidification section is really important if you live in a humid climate zone and you want to do a separate calculation for your peak latent conditions. We highly recommend that. That is a topic which could warrant an entire presentation, so we won't get into that right now. Now, orientations, we mentioned earlier how important that is, and I'm going to illustrate that right here. Look at the difference that 90 degrees, these are two load calculations of the same building, and the only difference between these two files is the orientation. I've only rotated the building 90 degrees. This is a building that had a lot of glass in it, and this is where we'll particularly see big differences in the outputs for rotations or in orientation. So look at that net gain column. Here we've got about 60,000 BTUHs for this first orientation, which I guess we had the front door facing north, and then rotated the building 90 degrees so that the front door was facing east. And this resulted in almost 2 tons. Look at this. So almost 84,000 BTUHs for this second iteration of the load calculation. And that is a difference of almost 24,000 BTUHs, and just quickly 12,000 BTUHs per ton. So that equates to almost 2 tons worth of cooling difference just by having the orientation of the building off. So that's really important to get that right. Now let's talk about assembly specifications. So what do we mean by that? We're talking about the wall insulation and type, the roof and attic insulation and type, the window SHGC and U factor, the roof material is another thing that we need to look at. You can find some of this information on the reports that come out of the load calculation. And again, Eric will be discussing these reports in more detail, so I'm not going to get into it, but there are ways for you to check what got input into the file. So for example, we see this says U value, it should say U factor and SHGC. Those two inputs can have a pretty significant impact on the results of the loads, especially if you have a lot of them. You want to make sure that the U factor in particular reflects the actual windows which are going to be installed. So if you have site-built windows that may not be thermally broken, that's something that you're going to want to pay attention to and make sure you get right. Wall insulation and assemblies. The one thing I'll say about that that's not self-explanatory maybe is that we're seeing a lot of buildings that have a ton of glass and metal in them. So if you've got metal elements like I'm talking about steel columns for structural or just for aesthetics that are running from exterior to interior without any thermal breaks, you need to make sure that that gets accounted for somehow in the load calculation, because that can have very significant impacts not only on the cooling and heating loads that you'll see reflected in the load reports, but also just from a perspective of comfort. Your homeowners will notice a difference if you have not accounted for that. So again, that is a topic for which we could talk a lot about. So we will leave it at that for now. HVAC location, so your mechanical location is really important. We're seeing more and more that mechanical equipment is being located within the thermal envelope, which means that it's in, if not actively conditioned space, at least in passively conditioned space or buffer space. So most frequently that looks like a foamed-in attic. Usually spray foamed. You can have exterior insulation on your roof decking. You could also have blown-in bats, but the important part of that is the insulation located at the roof line. If it is, chances are good that you've brought your mechanical systems into conditioned space. And why does that matter? Well, let me show you. So again, I'm comparing two different files, having made only one change to that file. And that change in this case was the location of the mechanical equipment. So in this case, I've pointed out that your net gain, so again, when we say net gain, we're talking about the cooling load for the house. The net gain in this case is different by over a ton. So that's significant. And again, the only thing we've changed is you can see that in that the top load where you've got almost 74,000 BTUH of heat gain, which equates to your cooling load, and that had the mechanical equipment located in unconditioned space. And then when we moved that equipment into conditioned space by changing the specification for the roof assembly, relocating the insulation to that roof line, it's dropped the cooling load by over a ton. So that's a big deal. So, and next we're going to talk about the performance goals. That generally starts with energy code, and that's a minimum bar. And so if we're talking about our climate zone in Austin, Texas, we're in climate zone 2A, hot humid climate. And for ICC 2012, we've got an ACH, or air changes per hour, at 50 pascals of 5 or less. So that's our requirement. You've got cooler climates having a lower ACH 50 requirement of 3. But so that's the input we would generally use, unless we know that the building has a higher performance goal, for example, a passive house goal, so very tight. There is an input screen specifically for infiltration, and that's these are the numbers that we would use. So duct leakage, there's also an input required for duct leakage, and that describes how leaky is your duct system, which has bearing on your load, because if you have a very leaky duct system, obviously you're going to be losing energy, and you're going to need to generate more of it, your cooling or heating, in order to make up for that loss. So again, we generally start with energy code requirements. ICC 2012, again, is what we're still under currently, and that requires 4 CFM or less per 100 square feet of conditioned floor area. I won't go into what that means, but suffice it to say that, again, if you know that you're going to have very tight very tight duct system because of a green building standard that you're shooting for, you may want to account for that. We're just going to talk briefly about zoning, and just note that it's very useful to know ahead of time when you're doing a manual J to know how you would like to divide your interior spaces according to zones. So you'd want to look at things like space use, load diversity, and just the possible duct design. In other words, just what's the practicality of running ducts. We're going to pause there and come back in just a minute to talk about internal loads. Okay, welcome back. So here we're talking about internal loads because this is another really important input that that goes into the load calculation. And so what is an internal, what are we talking about when we're talking about internal loads? We're talking about people, appliances, any source of humidity or moisture like showers, utilities, appliances. And why this is important is that people and appliances generate not just heat, but also humidity. And those need to be added into the loads, which are just being generated by your exterior conditions or weather. I want to point out where you can check out what a latent load is what describes the humidity load. And